Good morning. So we are continuing with where we were at on Friday. So determining quadratic equations part 2. So we want to determine the quadratic function that passes through, it's giving us 2 points this time, right? We need 3 points at least, but right now we have 2, and then we have the axis of symmetry. Well, if we think about a parabola, okay, your vertex is either your maximum or your minimum, the lowest or the highest point. So here we would have our minimum. Your axis of symmetry is what goes through your vertex, right? It's what cuts your parabola in half. So it's symmetrical. Each half is symmetrical to the other half. So if I have a point right here, let's say it's 2 away from my axis of symmetry, then I'm going to have a point on the other side that's exactly the same 2 points away from the axis of symmetry. Same here, if you have a point right here that's 1 away, you have a point that same place on the other side, 1 away. Okay, it's symmetrical. So if I graph my points 0, 3, and 5, 8, and then here's my line of symmetry, then I know I'm going to have equal points on the other side of my line of symmetry, right? So 0, 3 is 1 point away from my -1 line, right? 1 point away at 3, so 1 point the other direction, and I would have my symmetrical point, okay? Same with 5, 8. 5, because we're looking at our x equals 1, -1. So we're looking at my x value. 5 is 6 away from -1. If you need to count it, you can. So if we went 6 away the other direction, 6 away from -1 would be -7. So we would be here. So we have -7, 8, and then we had -2, 3. And this one was 0, 3, and 5, 8. So you just need any 3 points. Y'all couldn't see this, sorry. You need any 3 points. I would stick with your original 2, and then just use one more, okay? So if you remember, this is our x squared column, our A, our B, our X. Our C column is always 1, and then we have our Y's, okay? So if I'm using, let's start with 5, 8, or let's go in order. We'll start with 0, 3. So 0 is my x, 3 is my y. My x value 0 squared is just 0, and then this column is always 1, right? So then we get our next point. My x is 5, this column is always 1, and then my y is 8. And x squared, 5 squared is 25. So then we'll go to our new point that we found, -2, 3, -2, 3, and -2 squared. -2 times -2. Negative and negative make it a +4. And now we can go put this into desmos.com/matrix. All right, so we plugged in all of our values into our matrix. We did the RREF for matrix A, and then this is what came out to be our answer. So now we're going to plug these numbers in that last column into our equation. All right, so we looked at it in our matrix. We ended up with this as our answer, which means we have y equals 0.14x squared plus 0.29x plus 3 as our answer. All right, so we already have our 2 points that we can go ahead and put into our matrix, 5, 2, 2, -2, and then we know this column's always 1s, right? So what we need is our other point that could help us finish off this matrix, and then let's do our x squareds. So 5 squared is 25, and 2 squared would be 4, okay? So here's our axis of symmetry, okay? What's gonna make our parabola symmetrical is gonna be the middle. okay? So what we want to do is find another point based on some symmetry here, right? So here at x equals 3, this point is at x equals 2. So 2 is 1 away from our axis of symmetry, which means we're going to have a point in the exact same spot, but on the other side of our axis of symmetry, right? And this point is going to be at 4, -2. So we can use that as our other point. Okay, so we have 4 as our x, -2 for our y, and then 4 squared would give us 16. Kind of ripped the paper earlier. Okay, so 16, and now let's put that in our matrix and see what we get. All right, so I went ahead and put in our numbers into the matrix. I did the RREF for matrix A, and then you can see on the right we get these answers, 1, -6, and 6. So now let's put that into our equation and see what that gives us. All right, so here's the answer it gave us. Okay, so this is essentially our A, our B, and our C. So we get the equation y equals 1x squared minus 6x plus 6. And that would be our answer. Okay, so for this example, it's wanting to know which of these points is not a point on our quadratic equation that contains these points, okay? So the steps we need to take is first figure out the equation and then see whether these points lie on the equation or not, okay? So the first thing we're gonna do is build our matrix, right? So we have our x squared, x, this column's always 1, and then our y. So let's go in order. So 0, 4, 2, -8, 5, -11. We're just filling in our x's and our y's, right? So 0, 4, 0, 4, 2, -8, 5, -11. This column's always 1s. And then our x squared, so we're just going to square our x's. So 0 squared is 0, 2 squared is 4, 5 squared is 25. Okay. Now we're going to go put this in our matrix and figure out our solution. Okay, so when we plug this into our matrix, we get our answer on the right, the 1, -8, and 4. So now all we have to do is plug that into our equation, and we'll go from there. All right, so this is the answer it gave us, which means this is our answer, our A, our B, and our C. So we have y equals ax squared plus bx plus c. That means we have y equals 1x squared minus 8x plus 4 as our answer, okay? But I want to know which of these points are not on here, right? Which is not a point on our quadratic equation. So what I need to do is I need to graph it, okay? So we're going to go back to Desmos, but not Desmos matrix, just desmos.com, okay? All right, so I've graphed my equation. I typed it in. It's already graphed here in red. Now what I'm going to do is I'm going to plug in those points that it gave me. So the first one it gave me was 10, 24. Okay. We go ahead and label it. That's option A. Okay. Then we're going to do our new point, and that was 12, 60, and we can label that answer choice B. And then our third one it gave us was 15, 109, and that was answer choice C, okay? So now what I want to do is go to my graph and look and see which points are on it. So you can see A is on my line. A is a point that lies on my quadratic equation. And here's B. B you can see is not on my quadratic equation. It's not on my function, okay? And then C, you zoom in, you can see C does lie on the line. So the correct answer would be B, because B is not, it is the point that does not lie on my quadratic equation.